Class, this example will be of how to find the domain and range of a function that's given to us algebraically. We're going to consider the function f of x equals 4 divided by the square root of the quantity 6 minus x. The domain is the set of x for which the function is defined. What this means is that we need to find the x values for which there is no division by 0 and for which there is no square rooting of a negative number. This means that the quantity inside the square root must be greater than 0. If it were equal to 0, there would be division by 0. If it is less than 0, there would be the square root of a negative number. So what we will conclude after solving this inequality is that x must be less than 6. This allows us to say that the domain of f is equal to the set of x such that x is less than 6. Or in interval notation, the domain of f is the interval from negative infinity to positive 6, excluding the positive 6. The range of this function is a little more complicated to find. Let's ask ourselves several questions. First, is f of x negative for any x values? The answer there is no, because the numerator of the function is always positive, namely positive 4, and the denominator is always positive. So what this means is that f of x is never negative. There are no negative y values for this function. Next question, is f of x 0 for any x values? And the answer is no. This fraction can never be 0 because the numerator is 4. The only way a fraction can be 0 is if the numerator is 0. So this function never has a value of 0. Last question. Is f of x positive for any x values? And the answer there is yes. In fact, if we choose an x value from the domain, then we will end up with a positive y value. And what we will see, if we plug in a number a little less than 6, say 5.9, that will yield a y value that is quite large, because we'll have 4 divided by the square root of 0.1. That will be a large y value. And as we get closer and closer to 6, say we plug in 5.9, 5.99, what we see is that the y values get arbitrarily large. Now, as we plug in numbers that are closer and closer to negative infinity, we will end up with a denominator that is very large, and 4 divided by a very large number is close to 0. It will never get to 0, but it will approach 0 as x approaches negative infinity. This allows us to conclude that the range of f is the set of y such that y is positive, or in interval notation, the range of f is the interval from 0 to positive infinity.